Alright, so for the review, this goes with quiz number 22, which is the quiz we're taking today. First thing is, number 1 on here says, is this a solution to the following system? Number 11, how do we know if a solution is a solution is a solution to a system, or a point is a solution? You're 15, but that's okay. That's okay. I called 11, but yes, you have to plug it in. So we plug it into the first one. When we plug it in the first one, we have x plus y minus z equals 7. Okay? Pretend the right side doesn't exist. Put the left side in your calculator. Or do it in your head, whichever you prefer. So we have 1 plus 2 minus negative 4. 7 equals 7. That one works. Next one is x is 1 minus 2 times y is 2 plus 4 times z is negative 4 equals negative 19. Cover up the right side. Let's plug the left side in our calculator. 1 minus 2 times 2 plus 4 times negative 4. The left side's negative 19. The right side was negative 19. It works there. Try it in the third one. 2 times 1 minus the y was 2 plus 3 times the z is negative 4 equals negative 12. 2 times 1 minus 2 plus 3 times negative 4. Negative 12 equals negative 12. It works. Since it worked in all three, we have to answer yes. If it does not work in all three, your answer would be no, and you can stop when it doesn't work. So if it didn't work on the first one, you wouldn't have to move on. We okay with that one? Most of you guys have been doing pretty good on that one. That one's been on the last couple quizzes. Write a system of 3 equations with a solution of 2, 3, negative 1. Remember, this is the one where you get to make up the equation, the left side of the equation. So number 4, make up something with x, something with y, something with z. 5x plus 2y. Hold on, we need another plus or minus. Plus how many z? 7z equals. We don't know what it's going to equal. We'll have to figure that part out. So now we go to our calculator and we type in, okay, if we have 5 times, what's the x supposed to be? 2. Plus 2 times the y is supposed to be a 3. Plus 7, the z is supposed to be a negative 1. That one has to equal 9 for it to be a solution. There's one of them. Number 10, make up another equation for me.
8x plus 3y plus negative 3.
So minus 3z?
Yeah, minus 3z.
Okay, we'll change it to minus 3z. You can write plus negative 3z or minus 3z. Doesn't matter. Equals, we don't know what it's going to equal. You got to go to your calculator and get the right answer for that part. But the left side, you get to make it up however you want. So 8 times the x was 2 plus 3 times the y was 3 minus 3 times the z was negative 1. I plugged it in. This one will have to equal 28 for it to be true. Number 15, make up another one for me. X plus y minus z equals. So we have a 2 plus a 3 minus a negative 1, 6. Write down 6. Some people are doing this one correctly. Some people are not having x, y, and z in here. So in order for it to be an equation, it has to have that x, y, and z in there for it to be a solution, an equation, or a system of 3 equations in 3 variables that is a solution, has a solution of 2, 3, negative 1. Is that okay? All right, next we are going to find the element. So this one, we're going to use matrix A, row 1, column 2. Right? The rows always come first in matrices. So row 1, column 2. Here's row 1. Here's column 2. So You go down 1, this is the first one, over to the second one, negative 7. Right? Give me a 1 to 5, I know how to do those ones. I got those down. Cool. Number 3, what's B1 to? Negative 10. So first row, second column, negative 10. There we go. All good? What are the dimensions of number 5? Number 11. A 1 by 3. And what are the dimensions of number 6 here? Number 12. 3 by 2. Number 14. How do I go about multiplying by a scalar a number out front? Yeah, number 14. Number 14. Well, how do you think you would do it? You have a negative 2 out front and all those numbers on the inside. Multiplying by a scalar. I bet if you guess it right. Distribute it to all the numbers. So you're just going to multiply all of these numbers by negative 2. So, negative 2 times negative 1 is a positive 2. Negative 2 times 2 is negative 4. Negative 2 times 6 is negative 12. Negative 2 times negative 3 is a positive 6. Negative 2 times negative 4 is a positive 8. Negative 2 times 7 is negative 14. And there's your answer. There's no work to show. All we did was multiply negative 2 by all 6 numbers. Easy peasy. Nothing's trying to trick you. Okay. Number 5, how do I add matrices together? What's that? Yeah, you normally would add like the first row, first column with the first row, first column, but you can't here. Why not? This one's not possible. What was the reason? Yes, to add, you have to have the same dimensions. I need one more piece of information here to get my full 3 points on a quiz, though. 1 point comes from saying not possible. 1 point tells me why. My third point is to support my reason why. What's that third thing we need here? The actual dimensions. So what are the dimensions of this first one? Plus the 2 by 3. Good. So we got to write in those dimensions to get our full points. All right, let's look at number 9. Can we add these two together? Yeah. They have the same dimensions, right? So what is 1 plus 2? 3. How about 0 plus 4? 4. How about 0 plus 5? How about the 1 plus negative 1? And we're done. A lot of people got this one wrong last week because they looked at this, and what is this matrix called? That is an identity matrix. However, it's only the identity for multiplication. Okay? The identity for adding would be if it's all zeros, because when you add 0, that's when it doesn't change. This is the multiplicative identity matrix. So it's the identity matrix when we're multiplying, not when we're adding. If we're adding, we're going to have to add 1 to 2. That's going to change it. Do you see that? So some people got that wrong last week on their quiz because they saw something like that and automatically assumed, oh, identity matrix. Here's my answer, 2, 4, 5, negative 1. Got to be careful on that. Number 10, can we do it? Can we subtract? Yeah, okay. What's 3 minus 5? Negative 2. What is 1 minus 1? 3 minus 7. Done. Nothing's trying to trick you on those adding and subtracting ones. Those are the easy ones. We like those. They take very little time. Right? me a 1 through 5. How do we feel about the adding, subtracting, and scalars? So the 3 that we've done so far, how do we feel about those ones? So pretty good? Cool, cool. All right, then let's try number 11. 11 is one of the multi-step ones. Number 11, can you explain how I'm going to go about this one? Okay, so this one I'm going to multiply everything by what? By 3. Okay, so I multiply everything by 3. I get negative 6, 15, 30, negative 6, negative 3, negative 21. What do I multiply this one by? Sure. What's the sign between these two? What is it? It is now addition. If you are going to distribute the negative 2, you need to think about this as plus a negative 2 and distribute the negative 2 through so that changes to an addition sign. If you leave it subtraction, then you'd have to only distribute the 2, not a negative 2. Okay, that's different. Some people are getting confused on that. If you are distributing a negative 2, change it to plus a negative 2 and then distribute the negative 2. So this is now an addition problem. How do we add two matrices? How about number 1?
Like the same thing as number 9 with the negative 6.
Like we did in number 9. So what am I going to add here?
Negative 6 and 4.
Negative 6 and 4, I get negative 2. And then 15 and 12, and I get 27. And 30 and negative 6, and I get 24. Negative 6, negative 8, negative 14, negative 19, negative 23. Is that okay so far? All right, number 12. How do I multiply matrices? What's the first step in multiplying matrices? How about number 10?
You multiply the first one by the second one, right?
Okay, I'm going to multiply the first one by the second one. How do I do that, though? What's my very first step before I even get to multiplying? I have to write something out. Dimensions. What are the dimensions here? What are the dimensions here? Why do I need to write out dimensions? Make sure you can even do it. So how do I know I can do this? No, not. You look at those middle numbers. Okay, are they the same?
Yes.
So okay, I can multiply them. Take out that middle man once those are the same. What's your answer going to be?
Well, is that identity one?
It is going to be the same, yeah, because of the identity. But your answer has to be a 2 by 2, right?
Right.
Okay. Because you take out that middle man, that's how you can see what the new dimensions are going to be. But yes, as you said, this is the identity matrix. So if I just write down identity matrix, that's me showing my work. I don't have to actually go and do all the multiplication then, so this problem just became a lot easier. This is the identity matrix. That means this has to be my answer because it's multiplication. But even though that's the identity matrix, I want to make sure that this works, because sometimes you can't multiply it. You could still get undefined if you multiply by an identity. So I want to make sure I write this out first. So can I do it? Yep, I'm going to have a 2 by 2 answer. Is my answer a 2 by 2? Yeah, it matched. So this worked out. I pointed out that's the identity matrix, and that was my answer. Okay. All right, let's look at number 13. This is another multiplication one, so what should I do first? How about number 4? What do I do first? Find the dimensions. What are the dimensions of the first one? A 2 by 1 times, what are the dimensions of the next one? 1 by 2. I look at these middle numbers. Can I multiply those? Yes, because they're matching. Cover that up. What's my answer going to be? A 2 by 2. So when I write my work box, I'm going to make sure my work box is a 2 by 2. What do you circle in the first one, rows or columns? Rows in the first, columns in the second. Okay? I have 2 rows, I have 2 rows, I have 2 columns, I have 2 columns. In my first row, I'm going to have 1 in each of those boxes. In my second row, I'm going to have -2 in each of those boxes. Since I only circled one number at a time, I'm only going to have 1 pair of numbers in each of these boxes. In the first column, I have the number 3. Second column, I'm going to use the number -4. And from there, I can get my answer. 3 times 1 is 3. 1 times -4 is -4. -2 times 6 is -6. -2 times -4 is a +8. And that there is my answer. Are we okay with that one? All right, here we go, number 14. Number 15. How do I do number 14? That's the multiplication going on. What am I going to do? No, 15. 15 on number 14. Sorry. Write down the dimensions first. Okay, so what are the dimensions here? 1 by 3 times, what are the dimensions here? Can I multiply these? No, you cannot. A lot of people assume, yeah, they're the same dimensions. Multiply by -2 and 8. No, 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 no. That does not work with multiplication. So, we say that this is undefined or not possible. I don't care how you phrase it. But either way, we're not multiplying these two things because the number of columns in the first matrix do not match the number of rows in the second matrix. Okay? Rows, columns, rows, columns. So the columns in the first do not match the rows in the second. That's how we're going to say that this is undefined or not possible, because those numbers would have to match. If you circle a row and circle a column, you did not circle the same number of numbers. That's not going to work out. Okay, you circled 3, you circled 1, it doesn't match. Okay. All right, can I go ahead and flip this over? Number 15, another multiplication one. How about number 16? What am I going to do first? Number 16. I'm doing some multiplication here. What's my first step? The dimensions. Good. Write out the dimensions. Okay, so what are the dimensions here?
3 by 3.
Good. And what are the dimensions here?
3 by 2.
Good. Look at those middle numbers. Can we multiply those? Yes. What's my answer going to be?
The same thing because it's the identity.
Oh, yeah, it's going to be this thing because that's the identity. Good. It has to be a 3 by 2 because you can take out that middle man. 3 by 2. We can say that this is the identity matrix. We could multiply them, so I can move on. That's the identity. I am multiplying, so my identity is an identity. Okay? Not like the adding. If you add this matrix, it changes it. Okay, so then this is going to be your answer, so we'll write that out. 4, 5, 6, -7, -2, -3. That's your answer. Cool, cool. Nice job. Number 16. How about number 12? Okay, what are the dimensions of the first?
2 by
And the dimensions of the second?
3 by 1.
Can you do it?
Yeah.
Yep, the 3's match. So what is your answer going to be?
It's going to be 2 by 1.
It's going to be a 2 by 1. Take out those middle numbers and you're off with the 2 by 1. So I need to write out my 2 by 1 workbox. Okay. Circle the rows in the first. Circle the columns in the second. Notice your answer has 2 rows, 1 column, 1 column. Okay. So in the top row, the numbers I use are 2, 4, and 6. In the bottom row, the numbers I use are -1, -5, -3. In the one and only column, I use the 1, 2, -8. So I have 1, 2, -8, 1, 2, -8. I notice that every circle that I did has 3 numbers in it, so I know that each of my boxes in my workbox has 3 number pairs. Okay. And you're adding these up. From here, you can do a second workbox or you can go right to your calculator. It does not matter to me. As long as I see that workbox, that's sufficient enough. But you can type this right into your calculator. 2 times 1 plus 4 times 2 plus 6 times -8. So go ahead and type those in for me. Number 11, did you get that top number? What'd you get? So you got 2, 8, and -48, is that what you said? Okay, so then what do those add to? -38? Okay. Number 10, did you do the bottom one?
No, I did not.
Okay, can you do that bottom number for me?
Yeah.
Do you have a calculator?
I got those.
Okay, got it.
35.
-35? I don't think that one's right. This would be a 1, or sorry, a -1, a -5, a +24. Or that's -10, sorry. So -1, -10, that's -11, and a +24.
44, -11.
Yeah.
So
13?
14.
Maybe we should grab that calculator.
Yeah. Got a second guess.
Second guessing yourself. Yeah, go check your phone for one. I think Mrs. Fox doesn't know what she's talking about.
Yeah, you know.
I knew. All right, number 17. Number 17 here. Number 3, what's my first step here for number 17? Write the dimensions. The dimensions here are 3 by 2. Dimensions here are. Can I do this? Yes, those middle numbers match. Take them out. What are my answer? What's the dimensions of my answer? 3 by 2. So I'm going to write out my 3 by 2. Workbox here. Okay. Number 1, what do I circle in the first matrix there? 0 and 2. So that's a row.
Yeah, the row.
And then the next row and the next row, right? Okay. Then what do I circle in the second box?
2 and 6.
The -2 and 6, and then the 1 and the 7. Good. So I have 3 rows. I have 3 rows. In the top row, what numbers do I use? 0 and 2. So 0 and 2 go in every box in the top row. In that middle row, what numbers am I going to use? -3 and -1. They go in every box in that row. In that last row, that bottom row, what numbers do I use? 5 and 4 go in each box. All right, now we move on to the columns. In the first column, I look at the first column. What numbers have to go in all those boxes? -2 and 6 go in each box. And in the next column, what numbers do I use? I use what?
6 and 7. Oh, wait, sorry. 1 and 7.
1 and 7, good. And then remember, you're taking the multiplication, add the multiplication. So it's a plus sign in between those multiplication problems. Okay? So now we can go right to our calculator. If you want another workbox in there, that's fine, but you can go right to our calculator here. 0 times -2 plus 2 times 6. What do you get there? Number 1, I'm still working with you here.
You get 12.
12, good. How about in this box here, the 0 times 1 plus 2 times 7?
Give me 1 second.
Very good.
$14.
14 here. Next box. -3 times -2 plus -1 times 6.
You get 0. I got it.
6 and -6. Yeah, you should get 0. -3 times 1 plus -1 times 7. -10 there. 5 times -2 plus 4 times 6. 14. 5 times 1 plus 4 times 7.
Alright, 33.
Positive 33. Good. And that one's done. There's your answer. Number 18. How about number 4? Find the dimensions. The dimensions of the first one is what? 3 by 3. The dimensions of the second one is? Can I multiply these together? No. So it's not possible. Why is this not possible? These middle numbers don't match. So I need to say this is rows, columns. The columns, or number of columns, in the first do not match with the number of, this is rows and columns, so rows in the second matrix. All right, moving on to number 19 here. Can I scooch this over? Number 9. Let's see if you remembered your number. You came in late. What's my first step in multiplying these matrices? Writing out the dimensions. What's the dimensions of the first? 3 by 2, good. And the dimensions of the second one? Can I multiply these?
Yes.
Yes. What's my answer going to be? 3 by 1, good. So I would do a 3 by 1 workbox. Okay. Remember, we're going to circle the rows in the first. We're going to circle columns in the second. There are 3 rows. There are 3 rows. There is 1 column. There is 1 column. In the top row, numbers 1 and -4 go in each box. Oh, look, there's only 1 box for that top row. In the middle row, I'm going to use the numbers -2, -5, and in the bottom row, I'm going to use numbers -3 and 6, based on what I circled. In each of the boxes in this first column, I have to use -1 and 2. And from there, I know that I'm multiplying these, then adding, multiplying those. Multiplying these, and adding them together. So there's a plus sign in between those pairs of multiplication. From there, you can do another workbox, or you can go right to your answer. 1 times -1 is -1, plus -4 times 2 is -8. -1 and -8 is -9. Did I do that right? Okay. -2 times -1 is a +2. That'll be a -10. +2 and -10, -8. And +3 and 12 is 15. How's that look? How about number 20? Take a look at number 20, and how could I go about this problem? What are we thinking? What would be my step here in number 20? Do we see anything? This is the new stuff we talked about the other day, where whatever we have here, we have to kind of know those properties and the steps that we can take in order to do these. Do I have to multiply this by this first? Or could I multiply this times this? As long as it's the same order, it doesn't matter where the parentheses go. That was that associative property we talked about. Very good. So what we can do here is we can change it and pretend that the parentheses are here instead. And pretend these ones don't exist. Why would it help you to change it to those two? Anyone see?
Less work.
Why less work? Look at this problem right here. We already did it. Didn't we just do that right here?
I went through and I just cut the parentheses and it was painful. So.
It was painful?
Yeah.
If you did do it, it is kind of painful because we haven't done this one yet. But see how if you change those parentheses, didn't we just do this problem? So you're allowed to do that, and you know to do that because it's the associative property. So this answer is going to be -9, -8, 15. And I'm going to write in here number 19. I'm not going to show my work for that because it's in number 19. Look to number 19 if you really want to see my work. Then I have still the 8, 1, I space that out a little more. 8, 1, -4, 0, 5. Now I have this problem instead. Well, that just cut down a heck of a lot of work, right? So, now I have to say, okay, well, can I multiply these together? Because I knew I could multiply the first two. That was easy. I already did it. This is what dimensions? 3 by 1 times a 1 by 5. Can I multiply those? Yep, what's my answer going to be? 3 by 5. So, here we go. I'm going to look at the rows in the first. So in every box in the first row, I have a negative 9. Negative 9, negative 9, negative 9, negative 9, negative 9. Every row in that second, I have a negative 8, negative 8, negative 8, negative 8, negative 8. In the last row, I have 15 in every single one of those. In the first column, I'm going to have an 8 in each of those boxes. What do I put in the 3 boxes in that second column? What goes in all of these boxes? 8 came first, and then 1. And then next comes a negative 4. And next comes a 0. That'll be nice because those will just all turn into 0. And a 5 here. And then once we multiply those, we'll have our answer. Negative 9 times 8 is negative 72. Negative 9 times 1 is negative 9. 9 times 4 is 36. 2 negatives make a positive. That'll turn into 0. Negative 45. Now I'm just multiplying. You can use your calculator to multiply. Negative 8 times 8 is negative 64. Negative 8 times 1 is negative 8. Negative 8 times negative 4 is a positive 32. That'll be 0. Negative 8 times 5 is negative 40. $15 times 8, I don't know what that is. 120, thank you. 15 times 1 is 15. 15 times negative 4 is negative 60. 15 times 0 is 0. 15 times 5 is 75. And there's your answer. Number 15, you said you tried this one, but you got the parentheses. Is that what you got in the end?
I messed up on some of the math, yes.
You messed up on a couple of the couple of the boxes?
Just the
One of the columns?
yeah.
Okay. But overall, you pretty much had the right idea, though, right?
Yeah.
Cool. But do you see how much less work that is if you know one of those properties, as you are allowed to switch those parentheses?
Yeah.
So that's one of those things that you're going to want to make sure you know those rules, because that'll make it a little easier on you guys. All right, last couple. Number 21, we did not do a previous problem, so we're going to have to go through and actually do this one, where we multiply and then multiply again. So, a 2 by 2 times a 1 by 5. Can I do that? No, it's undefined or not possible. I'm just going to write ... to save us some time here. But we know we have to also write in why it's not possible, right? That the columns in the first do not match with the rows in the second. Okay, we've written it a couple times already, though. So, 22. How do I go about this one? So that one was going to be a hard problem, but because I couldn't do it one of the ways, then I just stopped there. Not going to be able to multiply those. Okay. 22. What do I do first? Add them. I have to add them because they're inside the parentheses. I could distribute this, and I'd have this times this, plus this times this, but why would I want to multiply twice if I don't have to? So add these two together. 3 and 1 make 4. 2 and 2 make 4. Negative 4 and negative 5 make negative 9. 7 and 6 is 13. And then I still have that other matrix. Give me a 1 through 5. I knew that's where I had to start. Okay, good. All right, now we have to say, can we multiply these? What are the dimensions here? 2 by 2 times a 2 by 3. Can I multiply them? Yeah, what are my answers? What's my answer going to be? So I'm going to draw a 2 by 3 box here. Okay. Circle rows in the first. Circle columns in the second. I circled 2 numbers every time, so each of my boxes is going to have 2 number pairs. Okay, across the top row, each of those boxes is going to have a 4 and a 4 in it. Across the bottom row, I'm going to have -9 and 13. This first column, I have -1 and -4. Middle is 3 and 2. Last is 5 and -3. I'm adding up each of those pairs. Then I can go to calculator work here. Four times -1 plus 4 times -4. I'm going to get -20. 4 times 3 plus 4 times 6, 18. Or no, sorry, 20. 12 and 8, 20. 4 times 5 plus 4 times -3. That one's going to be 8. -9 times -1 plus 13 times -4. Thank you. -1 here. -9 times 5 plus 13 times -3. -84. That would be your final answer. Okie dokie. All right, let's look at number 23. Do we have questions on 22 before we move on? All right, 23. What should I do first? You have to multiply before you add. Okay. First off, though, when we multiply these, can we multiply them? And will I be able to take this answer and add it to that one? So I'm going to have to do a little bit of work here. Just thinking ahead, because I don't want to waste all my time multiplying this if I can't get an answer in the end. Okay. So what are the dimensions here? 2 by 3 times a 3 by 1. Can I multiply these? What's my answer here going to be? A 2 by 1. Can a 2 by 1 add with this here? Can a 2 by 1 add with this here? What are the dimensions of this one here? Isn't this a 2 by 1? When you add a 2 by 1 plus a 2 by 1, can you add them? Yeah, the matrices have to have the same dimensions if you are adding. So it's very important that you check that ahead of time, because we could have just saved us a heck of a lot of time if it was not possible. So let's go to multiplying these. There's my 2 by 1 answer for this. Plus, I know I'm still going to add that 2 by 1 there. So you can write that in now so that way you don't forget about it. Alright, so I'm multiplying here across the first row, across the second row. I switch colors here. First column and only column. So, top row is 2, 4, -9. Bottom row is 1, 0, 3. In the whole first column, I'm going to have a -4, a 6, a 7, a -4, a 6, a 7. And I'm adding these up. So whatever answer I get there, I'm going to add it to this 1 by 3. So let's figure out what we get here. 2 times negative 4 plus 4 times 6 plus negative 9 times 7. Negative 47 for that first one. And 1 times negative 4 plus, that's going to turn into 0, plus 3 times 7 is 17 for that one. All right, last step is to just add them. What do you get on the top? Negative 47 plus 1. Negative 46. 17 and 3 make 20, and that's your final answer. So far, so good. All right, last one we're just going to talk about, and then we're going to take a quick break so we get started on our quiz. Can someone walk me through my steps on what I would do in this last one? What would be the first thing I would want to do? Look at the dimensions. So I would look at the dimensions of this one here is a 3 by 1 times a 1 by 2 plus, so we'd have a 3 by 2 times a 2 by 2. Can I multiply these first two together? Can I multiply these second two together? Yes. So the first thing I would do is I'd multiply those and multiply those. And what I get here is a 3 by 2. I'll show you what that answer is. It looks like this. So when I multiply the first two, that would be the answer I get. Plus, when I multiply the second two, I also get a 3 by 2. And it looks like this. Will I be able to add those two matrices together? Because PEMDAS tells you that you have to do the multiplication, before you can add those together. So can we add these together now? Yeah, they have the same dimensions. So I would add it. I'd have a 2 by 3. I'd have negative 8, negative 7, 9, negative 10, 2, negative 1. And that would be my final answer.